Back in the day, steel wire was something we'd see coming off those old manual mills, sparks flying everywhere. But what Patini's doing today? It's a whole different ball game, folks. Welcome to their state-of-the-art facility, where tradition meets cutting-edge technology. The journey starts in their electric arc furnace, where scrap steel gets melted down at temperatures exceeding 3,000 degrees Fahrenheit. It's like watching lightning trapped in a crucible. Once molten, the steel flows into continuous casting machines that form it into billets. Those are solid rectangular bars, typically 8 by 8 inches. Now here's where it gets fascinating. These billets head to the rolling mill, where they pass through a series of progressively smaller dies. Think of it like making pasta, but with steel that's hotter than lava. Each pass reduces the diameter while increasing the length. What started as a chunky billet becomes a thin rod through this continuous hot rolling process. But we're not done yet. The wire rod then goes through a process called drawing. It's pulled through diamond-coated dies at incredible speeds. Some lines run at over 100 feet per second. Between each drawing stage, the wire gets heat-treated in controlled atmospheres to maintain its strength and flexibility. This annealing process is crucial. It's what gives the wire its characteristic properties. Finally, the wire gets coiled onto massive spools, each weighing several tons. Patini's automated systems ensure consistent diameter, tensile strength, and surface quality. From construction rebar to delicate springs, their wire finds its way into thousands of applications. It's American manufacturing ingenuity at its finest, producing millions of tons annually with precision our grandfathers could only dream of. Remember when machine shops smelled of cutting oil and echoed with the whir of manual lathes? Those days were special, but what we're seeing here with Hypermill software on the DMG-DMC65 monoblock is manufacturing artistry taken to a whole new level. This German-engineered machine is a 5-axis marvel, meaning it can position and cut from virtually any angle without repositioning the workpiece. The monoblock design, one solid cast iron frame, eliminates vibration, the enemy of precision machining. We're talking accuracy down to 5/millionths of an inch here, folks. The process begins with a solid block of 6061 aluminum alloy, the same material used in aircraft components. The programmer uses Hypermill CAM software to create toolpaths, essentially choreographing the ballet of cutting tools that'll transform this hunk of metal into a beautiful pen holder. First, the roughing operation removes bulk material using a half-inch end mill spinning at 12,000 RPM. The machine's 42-tool automatic changer swaps cutters faster than you can blink. High-pressure coolant floods the cutting zone, carrying away chips and keeping temperatures stable. Without it, the aluminum would weld to the tool, a machinist's nightmare. Next comes semi-finishing. Smaller tools, maybe an 1/8-inch ball nose, trace complex contours. The 5-axis capability really shines here, tilting and rotating to reach undercuts and pockets that would be impossible on conventional 3-axis machines. You can see the surface starting to gleam as the tool creates overlapping passes. The finishing pass is pure poetry. A tiny diamond-coated cutter spinning at 20,000 RPM kisses the aluminum with minimal force. The Hypermill software calculates optimal step-over distances, how far apart each cutting pass is, creating a mirror-smooth finish straight off the machine. No hand polishing needed. If you've ever tied rebar by hand on a construction site, you'll appreciate what the BSM-250 RROR automatic cage welding machine brings to the table. The process starts by loading longitudinal bars. Those are the long rebar rods running the length of the cage into the machine's feeding system. The operator sets the cage diameter and spacing parameters on the touchscreen controller. Meanwhile, spiral wire feeds from large coils mounted on the side. Here's where the magic happens. As the longitudinal bars rotate, the machine automatically feeds and positions the spiral reinforcement. Synchronized welding heads. There are multiple stations working simultaneously. Strike arc welds at precise intervals. We're talking resistant spot welding, where high current passes through the intersection point, creating fusion without filler material. The rotation speed adjusts automatically based on the programmed pitch. That's the spacing between spiral wraps. Typical production runs at about 6 feet per minute for a 3-foot diameter cage. The machine maintains consistent weld quality that hand tying simply cannot match. Ring rolling is one of those manufacturing processes that looks simple but requires incredible precision. The SIMASV CHV4100 is a hydraulic ring roller that's been perfected over decades of Italian engineering, and watching it work is like witnessing controlled chaos become perfect order. The process begins with a thick-walled ring blank, typically forged from steel that's been heated to around 2000 degrees Fahrenheit, that bright orange glow you're seeing. This blank gets positioned between two main rollers, the drive roll and the pressure roll. Think of it like rolling dough, but the dough is several tons of red-hot steel. As the drive roll rotates, it pushes the ring against the pressure roll. The pressure roll, mounted on a powerful hydraulic cylinder, gradually moves inward. This squeezes the ring, forcing the material to flow outward. The wall gets thinner, and the diameter grows, sometimes increasing by 300% or more from the original blank. But here's the clever part. While the main rolls work radially, there are also axial rolls, top and bottom, that control the ring's height and keep it flat. Without these, the ring would mushroom out like a pancake. The CHV4100's computer system coordinates all 4 rolls simultaneously, maintaining precise geometry. The hydraulic pressure is tremendous, over 500 tons of force, but it's applied gradually. Rush it, and the ring develops internal defects or cracks. The CHV4100 sensors monitor thickness in real time, adjusting pressure automatically. Experienced operators can hear the subtle changes in the machine's tone, knowing instinctively when to fine-tune parameters. These rings become everything from turbine casings to tower flanges for wind turbines. Krishna Forge Fitting in India represents that blend of old-world craftsmanship and modern efficiency that's keeping traditional forging alive. Their facility produces pipe fittings, elbows, tees, flanges that connect the industrial world. The process starts at the forge. Billets of carbon or stainless steel get heated in natural gas furnaces until they're glowing yellow-white, around 200 degrees. At this temperature, steel becomes plastic, ready to be shaped. Workers using long tongs transfer these billets to massive hydraulic presses. These presses, ranging from 1,000 to 5,000 tons capacity, house specially designed dies for each fitting type. When the ram descends, metal flows into every corner of the die cavity. The sound is thunderous, a deep boom that reverberates through the entire shop floor. Multiple strikes may be needed, with reheating between blows to maintain workability. Fresh from the forge, fittings head to heat treatment furnaces. This normalizing process relieves internal stresses and refines the grain structure. Controlled cooling is critical. Cool too fast and you get brittleness, too slow and you lose strength. Next comes machining. CNC lathes and mills create precise threads and seating surfaces. After machining, inspectors check dimensions with micrometers and thread gauges. Thread grinding represents the pinnacle of thread-making technology, and the Grindex BBN 500 CNC shows us why it's the choice for precision applications. The workpiece, maybe a threaded shaft for a ball screw or precision lead screw, mounts between centers and rotates at relatively slow speeds, typically 60 to 100 RPM. The grinding wheel, spinning at 10,000 RPM or faster, is specially dressed to match the thread profile exactly. Getting this profile right is critical. Even microscopic deviations affect thread function. The CNC system synchronizes 3 movements simultaneously: the wheel feeding radially into the thread depth, traversing along the thread length, and the workpiece rotating. This creates a helical grinding path. The BBN 500's rigid construction, Swedish precision engineering, eliminates vibration that would mar the thread surface. During grinding, coolant floods the contact zone. This isn't just about cooling. It flushes away microscopic particles that would otherwise embed in the wheel, dulling it. The final pass, called sparking out, removes no material. The wheel just kisses the surface, polishing it to mirror smoothness.